Hello everybody, we'll be solving Leetcode 121 best time to buy and sell stock. So this problem is easy and you would probably classify it under the sliding window pattern. Let's try to read the problem first and then attempt to solve it using brute force. So it says that we are given an array of prices where each price or the I for each prices of I is a price of the stock at the ith day. Okay. And we want to maximize the profit by choosing a single day to buy the stock and choose a different day to sell it. So essentially we want to buy low and sell high, similar to how you would run in any single stock market. You buy low, sell high. So you'll be given an array here. For example, we've taken an example here. So 7, 1, 5, 3, 6, 4. So if you were to buy the stock on 7, on which is the first day, and sell it on the second day, in this case the first day because these are ith, so selling it on the first day, you would end up with a profit of 1 minus 7, which is equal to negative 6, which is essentially a loss. So you don't want to do that. So what you would want to do is you want to find the point where you can buy at the lowest price and sell at the next highest price. If we were to approach this using brute force, you could essentially iterate to the array, and for each value iterate to the rest of the array and check which value will give you the highest profit. So I could do 1 minus 7 gives me minus 6, same thing, not highest. So run the same thing at 5 minus 7, again minus 2, 3 minus 7 gives me minus 4, again still minus 2 is the highest we have, but it says that we cannot achieve any profit and return 0. So we need to have at least greater than 0 value in terms of profit. So we just iterate this whole process to the entire array and then repeat it for each. Then we repeat it for each element. So again, once we're done with 7, we do the same thing with 1, repeat. And continue this for the rest of the array until the second last element. So 1, this is an approach where you have to iterate to the element array and then iterate for every other value in the array. So you can easily say that because you have to iterate to the rest of the array for every element, you can say that this is O of n. This is an O of n square complexity, which is fine in this case, but we can do better. Let's try to identify what we might be missing here. So if you were to take the array and visualize it as a graph, you can notice the values shown here in a much better form. So you know that if you were to buy something and sell it the next day here, it's going to result in a negative value. So in that case, we reset or we buy it on the day we found that our profit was negative. So instead of buying it on on the 0th day, we buy it on the first day now. So our profit goes from, well, not yet. So we buy it here and then we sell it on the next day. So now when we buy on 1 and sell on 5, our profit is 4. But if we were to go again to the next day, you can see that if we were to sell it on 3 as shown here, 1, so you'll end up with a profit of 2, while 4 is the previous profit that you had, so our max is still going to stay 4, and we'll continue to go to the next element until we have a negative profit. So we go from here and we sell, instead on this day we sell it on the 4th day. 4th day we sell it for 6. So 6 minus 1 is going to give us a profit of 5. Cool. So 5 is now our max. So we can just say max equals max equals 5 right now. But we can still go further and see if there's any potential opportunity for a higher value. So we go to the next, which is the last day, and sell the value there, and we sell it at 4. Again, 4 gives us a value or profit of 3, which is still lesser than our current max here. So we can basically print out that the max is 5. So if I were to code the solution, first start off by defining a max profit, setting it to 0, and we'll just add a return statement here. Next, we want to have a pointer which keeps track of the day we buy the stock. So in this case, we'll say curve buy to point to the index or the day on which we buy the stock. So initially, let's keep it to 0, and then so what we'll do now is we'll iterate to the prices. So I is equal to 0. Well, we'll start with I is equal to 1 because you want to start from the next day. I is less than. So we iterate to the array, to length of the array of the prices, and then what we'll do here is we'll calculate the current profit. So profit we'll calculate by comparing the prices with respect to the ith value minus the current buying index that we have. So now we'll update our max profit with the profit value that we have calculated. So we'll use a math.max to compare and update the max here. So we'll use max profit and the current buy. So this will update the max profit with the current profit that we have. In the case that our profit is less than 0, what we want to do is we want to update our current buy to the ith index. So what this does is that it enables us to buy it at the lowest price while also keeping track of the previous profits via max profit. Now let's run this code, and you see we have an 87.4%, which is good enough for us.